Section 3.3 is solving equations with variables on both sides. I can solve equations with variables on both sides. It's our learning target and what we're shooting for here. We can solve equations with variables on both sides of the equation by getting all of the variable terms on one side of the equation and the constant terms on the other. So here in example 1, we're going to solve. The first thing we want to do, always, is to make sure that our left expression is as simple as we can get it and our right expression is as simple as we can get it. So here we have no parentheses to get rid of and no like terms. 7n minus 5 is as simple as we can get it, and 10n plus 13 is as simple as we can get it. So now if we look, I have variables on my left side and on my right side, and I want to try and get them all together because ideally we want to isolate our variable. So we can't do that if we have them in too many places. I have 7 on the left side, 10 on the right. And since 7 is smaller, that's the one that I'm going to move. So right now I have a positive 7. I want 0 n's on that side. So if I subtract 7n, okay, 7 minus 7 gives me 0 n's. And that's what we hope for. If I change one side of my equation, I have got to change both. So since I subtracted 7n on my left side, I have to do that on my right side as well. I did not change my constant terms. I still have a negative 5 and a 13, positive 13. But as far as my n's go, 10 n's minus 7 n's means I only have 3 n's left. And now once we get to this point, it's just like we did in section 3.1, two-step equations. My variables being multiplied and added, so we get rid of our addition first. Okay, by subtracting. We have plus 13, we subtract 13, and that's how I get to 0. So again, we tried to get all of our variables on one side, all of our constant terms on the other, and that's what we've accomplished here. Negative 5 minus 13, same signs, we add them up, give the common sign. And in that step, I did not change my variable term. Now, my variable is being multiplied by 3, so we get rid of it by dividing. And here we get n equals negative 6, or negative 6 equals n. To check that, we plug it back into our original equation in both spots. So I didn't change anything except where my n's go. I'm going to make those negative 6's. Now we simplify. Multiply first, negative 42 and negative 60. Sorry, this is a minus 5 equals negative 60 plus 13. Gives me a negative 42 equals negative 47 equals negative 47, which checks we are right. Feel free to pause here and give it a try. First thing we want to do is double check and make sure that our left side is as simple as we can get it and our right side is as simple as we can get it. Both of those expressions here are completely simplified. So now I look. I have variables on the left side and variables on the right side. I want to try and get them together. Since 3 is smaller than 5, 3 is the one that I'm going to move. Right now it's a positive 3. I get rid of 3 by taking it away. 3 minus 3 is how I get to 0. And if I change my left side and change my right side, I have to change my left side as well. 3 minus 3 gives me 0. That's what we're looking for there. 5 minus 3 gives me 2, and I still have the n with that. We put our like terms together, so since they both have n's, we can combine them. I did not change my constant terms. I still have that minus 2 and my 6. Now, both sides were as simple as we can get them, so we started moving pieces. We got all of our variables together on one side. We want to get all of our number parts together on the other, our constants. So, to get rid of a minus 2, I add 2, and that's how I get back to 0. 6 plus 2 gives me 8. These are still equivalent since I did the same thing to both sides, and I didn't change my 2n there. Now, n is being multiplied by 2, I get rid of it by dividing. And I get n equals 4. Here I plugged it back into my equation in both spots, simplified down, and since both sides equal the same thing, we are correct. Feel free to pause and give 2 a try if you'd like. My left expression is as simple as I can get it, and so is my right. So then I look. I have variables on both sides. I'm going to try and get them together. I have an 8 and an 11. 8 is smaller, so that's the one that I'm going to move. Right now it's a positive 8, so to get rid of it, I take away 8. Positive 8 minus 8 is how I get to 0, and that is our goal. We subtracted 8y. Whatever I do to one side, I have to do to both. 8 minus 8, 0. 11 minus 8 gives me 3, and I still have y's there. Okay, same thing. They're like terms. That didn't change, still y's. I didn't change my 4 or my negative 17. Now, we've accomplished getting all of our variables on one side, so we want all of our constants on the other. To get rid of a minus 17, we add 17, because again, that's how we get to 0. Negative 17 plus 17 is 0. 4 plus 17 is 21. It's still equivalent because I've only changed my equations by doing the same thing on both sides, and here I didn't change that 3y. Now, my y is being multiplied by 3, so I go ahead and get rid of it by dividing by 3. I get 7 equals y, or y equals 7. I plugged that 7 back into our original equation in both spots, simplified it down, got 60 equals 60, so we are correct. Now, feel free to pause and give 3 a try if you'd like. Again, my left side is as simple as I can get it, and so is my right, so I'm going to compare my variables right now. My coefficient or my number in front of my variable that's being multiplied, on the left side, there isn't one, so I know that it's got to be a 1. 1 times m. So when I compare 1 and 9, 1 is smaller. That's the piece I'm going to move. Right now it's a positive 1, so I'm going to subtract 1. I'm going to do it on both sides. So m minus m gives me 0. 9 minus 1 gives me 8. And I still have m's with that. I didn't change my constant terms, my negative 1 or my positive 15. We accomplished our goal of getting all of our variables on one side, so I need all my number parts on the other. I get rid of a plus 15 by subtracting 15. Negative 1 minus 15, same signs, add them up, give the common sign. It's still equivalent, and here I didn't change my 8m, but 15 minus 15 is 0. That's what we're looking for there. Now, the only thing left is my m is being multiplied. We get rid of multiplication by dividing. And I get negative 2 equals m. Here I plugged that negative 2 back into my original equation, simplified both sides down, got negative 3 equals negative 3, so we are correct. Sometimes when we solve an equation, we may find that it has no solution or that every number is a solution. So here, on example 3, when I simplify my left side, I distribute. I take that 5 times both pieces inside. We start with multiplication, so I keep multiplication. And that lets us get rid of that parentheses. I take 5 times everything inside. A 2x is one term, and a 1 is my second term. I'm going to simplify there. 5 times 2x gives me 10x. 5 times 1 gives me positive 5, so plus 5. Now, I'm going to move my variables so that I get them on the same side. So, I'm going to go ahead and subtract a 10x. Right now it's a positive 10, so I get rid of it by subtracting. 10 minus 10 is 0. 10 minus 10 is 0. So what I have left then is 5 equals, on my right side, all I have left is that 0. 10x minus 10x gives me nothing. Now we check, does 5 equal 0? Nope. So here it's going to be a no solution. There's no number we can plug in that'll make this true. We also can use this little symbol right here. It means an empty set or a null set. It means that there's no numbers that work. On 4, my left side is as simple as we can get it, but my right side is not. I have parentheses. So I'm going to go ahead and distribute to get rid of them. I take 2, since we started with multiplication, I keep multiplication. And I take that to each term inside, the 3x and the 1. Gives me 6x plus 2. And I have not changed my left side here. Now, my goal is to get all my variables together on one side. So I have a positive 6. I'm going to subtract a 6. X. 6x minus 6x gives me 0. 6x minus 6x gives me 0. Anything minus itself, 0. So all I have left then is 2 equals 2. Since that is true, we're going to say all real numbers for our solution. Any number that we can pick to plug in for x here is going to give us a true statement. We could pick 7 million. We could pick 3.1. I could pick negative 0.2. All of those are going to give equivalent solutions on both sides. So all real numbers. In example 5, wants us to find the perimeter of the square. Here it's important to note that we have a square. With a square, we know all of our sides are the same. So what that tells us is 2x and x plus 4 represent the same length. So we can set them equal to each other. 2x and x plus 4 have to equal each other because we have a square. So I have variables on both sides. Remember, if there's not a number in front, it's a 1, our coefficient there. I'm going to go ahead and subtract that 1x and move it to the other side so that all my x's are together. 2x minus 1x gives me just 1x. 1 minus 1 gives me 0, and I still have that 4. So x is going to be 4 here. That's helpful because now I can figure out what my side length is. 2 times 4 gives me 8. Or I could have plugged it in over here. 4 plus 4 gives me 8. Either way, I know that my side lengths are going to be 8 and 8 and 8 and 8. So with perimeter, we add up all of our sides, or we can use our formula for perimeter of a square, which is 4 times our side length. Either way, our perimeter is going to be 32 square units. So again, I know it's a square, so I can set my side lengths equal to each other. We solved for our unknown, our variable there, plugged it back in to figure out what this length actually represents, and from there, we can find our perimeter. So once I knew that each side was 8, I made all of my sides 8, and I can either add them up, 8 plus 8 plus 8 plus 8, or I can take 8 times 4, since all 4 sides are the same in a square, to get my perimeter, and I got 32 square units. And that's all I have for section 3.3.